Hello everyone, welcome to your own channel. My name is Muhammad, and in this series of videos we are going to master the VPC on AWS. In this video, which would be the part 1, we are going to create a VPC, create subnets, assign routing tables, and interact with them. If you're new to AWS or you want to increase your knowledge on VPC, stay with me. We're going to enjoy this video together. Let's go. So, in order to understand better how things are working, I'm going to create each step as a block. I'm going to show their diagrams, I'm going to connect them together so we can have a better look on what's actually happening on the servers. So, the goal of now is to first create a VPC. So I'm going to add the VPC. So this is our VPC. We're in the AWS account. We're creating a VPC. Now, what is a VPC? VPC is a private network. It's an isolated private network, meaning we can define communications for different services defined in this network. And then we can later have abilities to interact with services inside or outside of this VPC, or even with services outside of the AWS. So first things first, let's create the VPC on the console. So now we're in the AWS console. We're going to go to VPC. We're going to see the VPCs here. And we can see that there is one VPC created by default for each region that we choose. But we're not going to deal with it right now. What we want to do is that we want to create our own VPC, our own network, and then be able to set the features inside of it. So I'm going to do create VPC. I'm going to name it random YouTube VPC. Then we have to declare the range of the IPv4 addresses that we're going to assign in that block, right? So it says that the CIDR notation, which shows the ranges of IPs, should be between /16 and /28. Now, you can either do this mathematically using paper and pen, or you can use the online tools. I'm using this website, which is Arene, if I'm not mistaken, which lets you to put the CIDR notation and get the ranges or vice versa. So what I'm going to do is that I'm going to say that I need this prefix, meaning IP addresses starting from 10.0.0.0 upwards. But what is the maximum? So it says that the minimum, not the minimum, but like the maximum number of IPs would be /16 and the minimum would be /28. But what do they mean? So if I do 28, I can see that I'm having 16 IPs in that range. So if here I write 10.0.0.0/28, I'm telling the AWS account to create this network, which contains only 16 IPs inside of it. It would be the minimum number of IPs I can assign. So it's not, for example, you cannot create a VPC and have only 5 IPs inside of it. But since for now I'm just working with it, I'm not going to worry too much about the size of the IPs. So I'm going to take the most amount of IPs possible in this VPC. So I'm going to do /16, which gives me more than 65,000 IPs, starting from 10.00 up to 10.0255 to 55. And then here we can create the VPC. That would be it. So for now, we have created the block which contains the isolated network, and we have defined the range for all the values inside of it, all the IPv4 addresses inside of it. I'm going to create the VPC and it's ready. So now I have a network, right? I have a network, but it still doesn't have anything. So on the next step, we can create subnets. Now, what is the subnet? A subnet is a portion of the IP ranges inside the VPC, meaning with subnets I can create, again, separated parts of IP ranges, and then I can have, for example, one of them be able to interact with services outside of the AWS, or let's call it the public subnet, which is able to interact with the internet, and then have another one which is the private one, which we are not going to give it any connection to the outside world or any connection outside of this VPC for now. So I'm going to write public subnet here, and then I'm going to have another one here. So what I'm doing, I'm creating two separate parts of the range of the VPC that we defined, and then add features inside of it. So let's now go to the AWS UI. So now let's create the subnets inside our VPC. As we said, we have one default VPC, we created the other one, and now we have 3 subnets dedicated to that default VPC, but we want to create our own. So I'm going to choose the VPC, I'm going to give it a name, public random YouTube subnet, and then I'm going to choose any availability zone. I'm not really worried about it right now. And then here it says that I'm going to create a subnet of values, a small portion of IP ranges for this VPC that we define these ranges of values. And as we said, they started from 10.000 up to 10.0255 to 55. So there is more than 65,000 IPs in these ranges. Now we have to say which part of it do we want to take and dedicate them to this subnet. To do so, here I'm going to say, again, we have the minimum of /28 and the maximum of /16. So the minimum of 16 IPs or all of the ranges of the VPC. So I'm going to say I want them to start from 10.000 up to 10.0015, which would be this CIDR notation. Okay, and then I'm going to create the second one. I'm going to name it private random YouTube subnet. Again, for now, don't worry about the availability zone. And then the same thing here. It says that you have these ranges of values. What is going to be the subnet? I'm going to, since I dedicated the one from 0 to 15 to the public one, I'm going to say from 16 up to 31. So the next 16 IP addresses. Okay, and it shows here there are 16 IPs in this subnet and another 16 IPs in this subnet. And let's go. So we have created the subnets. Now let's have a really theoretical discussion on how we can use them. So now let's talk about the architecture. As we said, we have the AWS account, we have created the VPC inside of it, which is an isolated network. We have created subnets, which are parts of the network. And now the goal is to give internet access to the public one, and then avoid any internet access for the private one. Now, how can we manage that? The main tool is something called, which I'm going to put it like this. Let me put this here. It's something called a routing table. Now, what's a routing table? A routing table, for sure, it's a table that says based on the destination of the packets, based on the destination of the API request, based on the destination of whatever you want to do, this would be the target. So it allows us to define how we can navigate through other services through the subnets inside the VPC. Your VPC, when you create it, has its own routing table, and we'll see in the next few minutes that how it behaves. So basically, it says that for all the IP ranges inside of this network, have them locally. Meaning, if you see a packet with this destination IP, all you have to do is just search for it here inside of the VPC. That's why we say it's isolated. But in order to make things more sophisticated, we can define also different routing tables for each subnet. And then for the public one, we can say that, okay, let's have internet connection for this subnet. It's done by a tool called Internet Gateway. So basically, the Internet Gateway gives access to services that want to have interaction with the internet. So what we're going to do now is we're going to have a look at this routing table for the VPC that we created. Then we are going to create two other routing tables, and then we're going to define them and tell them that for this subnet, which is public, transfer the packets into the internet gateway, which then leaves the AWS account. And then for the other one, we're going to tell it to not do anything. We are going to define the internet access based on these two routing tables. So now let's go back to the AWS console. Okay, we are back here. Now let's first create an internet gateway. As we said, there is already one installed for the default VPC, but we have created our own VPC, our own network. So we have to find a way to interact with the outside world, with the internet. I'm going to call it the Random Internet Gateway, IGW. And then I'm going to create it. Okay, now it's created, but it's still not attached to anything. I have to attach it to the VPC. I'm going to choose the VPC that we created, and then I'm going to attach it. Perfect. Now the only part missing is the routing table. So we have the VPC here. We had the ranges of the IPs. We created two subnets for that VPC. We created the internet gateway. We have attached it into the VPC, so it's all defined. Now the only thing to do is to work with the routing table. Now this is let me refresh it because they have to be two. Perfect. So the one on the bottom here, you can see it's dedicated to this VPC, to the random YouTube VPC that we created. So it's the general routing table for this VPC. Let's have a look at the routing that's defined for it. So it says that for any destination in this range, which is the same range as the VPC that we defined, the target would be local. So it's basically saying that keep everything inside of this VPC. Now let's create our own routing table. I'm going to name it the public routing table. Let's have also the word random since we've used it a lot, random. I'm going to select the VPC and create. So if I go back, I have the public RT random. Let me create the other one. Let's call it the private RT random. Select the VPC and then create the routing table. So now we have these two, and let me also name the VPC. routing table random. So we have these three routing tables. Now, we haven't still said which subnet is going to take which routing table. So we're going to do it like this. We're going to choose it, go to subnet association, and then I'm going to say that it should be dedicated to the public one. I'm going to do the same thing for the private one. Subnet association, edit, private, and done. So now we have all of those three routing tables, and then we have to define the routes. So for the public one, I'm going to edit the routes here. I'm going to add a route, and I'm going to say for any destination. So this is the notation of saying for any IP. I'm going to say for any IP, go to the internet gateway. Which one? The one that we created and attached to this VPC, and done. Perfect. So now basically any services that are created in this subnet, in the public one, they're going to have internet access, which is awesome. Now I think in the next part we're going to, let's do this. Let's launch EC2 instances, one in the public one, the other one in the private one, see how this routing table affects them, and also then we can also speak a little bit about the security groups. So let's go back for now to the theory, and then we'll back to the console. Let's go. So here we are. We have the VPC, we have the subnets, we have the routing tables, and we have also made a connection here. We have made a connection from this public subnet to the internet gateway and then to the outside world. Now, let's do it like this. Let's create, or let's say, let's launch two EC2 instances. Let me take this, and let's say this is an EC2 instance. I don't know what's happening. I'm still using the pen. Okay, let me come here. This is the EC2 instance. Again, I don't know what's happening. Let me delete this. Let me get rid of these. Okay. I'm going to put this here, EC2 instance, take it and also put it in the private subnet. And then we also need to know that for each EC2 instance, there is a firewall outside of it. It's not related to the subnet. It's deployed in the subnet, but I mean, it only affects the service. It only affects the EC2 instance. So let me also give a shape for the security group. So like this, and then let's send it back. Please send to back. No, it didn't work. Let's do it like this, whatever. Let's take this. Okay, I'm going to add it like this. Now, these are the security groups. Now, what are they? They're basically a firewall. They define what packets can enter and what packets cannot. So even if we have internet connection into the public subnet, if the security group doesn't allow it, they will never reach the EC2 instance. And we're going to see their effects in the next part on the console. So let's create the EC2 instances. I'm going to launch an instance. I'm going to name it public I can type public random EC2. I'm not going to use any key pairs, and then on the network settings I'm going to edit it, because by default it will be deployed in the default VPC. So I'm going to choose my own VPC. I'm going to make it work in the public subnet. I'm going to assign a public IP to it. I'm going to create a security group for it. I'm going to call it SG underline public random. And then what does it say? So the inbound security group says that anyone, source type anywhere, meaning anyone, with the type of SSH on port 22 can have access to this service. So the security group is a firewall. It doesn't look at the routing table. It doesn't look at the VPC. It doesn't look at any other thing. It's like a layer just outside the EC2 instance, right? So it says if anything arrives that says I want to do the SSH on port 22, I'm going to allow it. And I'm going to leave it the way it is. Okay, so we have created an EC2 instance in the public subnet in our own VPC with its own security group. I'm going to launch it. And then I'm going to also launch another one in the private one. Launch an instance. Let's name it private without any key pairs. Again, I have to change the network setting or it will be deployed on the default ones. Choosing my VPC, the private subnet, okay. And then security group, private random. And I'm also going to give it a public IP just to show you that the settings are the same thing. Again, the security group says that I don't care about what's happening outside of me. The only thing that matters is that if I receive a request of SSH on port 22, I'm going to allow it. And let's launch both of them. Okay, let's have a look. So let me only look at the instances that are running. So these are my two EC2 instances, the public one and the private one. If I have a look here, I can see that they have their own security groups. And even if I come here, if I come to the networking, I can see that they are in the VPC that we made. The first one, which is the public one, is in the public subnet, and for sure the other one would be in the private subnet. Okay. So now let me show you something here. Each EC2 instance that we create has one public IP address and one private one. So the private one is going to be defined inside of the VPC. It's going to be used for the communication inside the VPC, which makes things much faster and more secure. The public one is used only for interaction with outside, with services that live outside of the network, right? It's the same for any EC2 instance that you generate. So now let's try to connect to them. I'm going to connect to the private IPv, to the public EC2 instance. Okay, I'm going to connect, and it's done easily, right? Because we had internet access for this EC2 instance. Now, what about the private one? What happens when I try to connect to the private one? What does it say? It says that the instance is not in public subnet, meaning this EC2 instance, although has the rule on the security group that says I'm going to allow any SSH into my VPC, into my EC2 instance, but the subnet itself has no internet access, meaning there is no way for us right now to have access to this EC2 instance, meaning it's an isolated service. It's a service which can only be reached inside the VPC, right? So for example, if we have a database, we don't want to give it public access. We don't want to leave it in a subnet which is public so that it can be attacked from an outside world. So we're going to put essential services in the private subnet, and then we're going to put other services that are designed to interact with users on the public one. So that's the main goal. That's the main feature of having subnets and having internet access through the routing table and the internet gateway. So here let's have a look at something. I'm on the public EC2 instance and I have internet access to it. If I ping a server to the outside world, I'm going to get the responses, right? Perfect. Now, let me show you something in the theory part on the architecture. So let's just for a couple of seconds, let's go there and we'll be right back. So let's have a look at what's happening. So when we do the SSH and we send the pings or we interact with this EC2 instance, we are basically going to go through the outside world, going to the internet gateway, going to the routing table. Basically, we are not going into the routing table, but we are navigated through the routing table to this EC2 instance, and then we are getting the responses. Now, let's do something a bit unusual. What if I want to have a connection here? How can I ping? So I'm going to do the ping, the same thing that I did for this EC2 instance in the public subnet for a server outside of the AWS. What if I want to ping the private one through the public one? It would work, right? Because we in the routing table here, this routing table, this one here, it says that for any communication inside of this VPC, stay local. So let's see how we can have this communication between the EC2 in the public and the EC2 in the private. So let's go back to the console. So if I want to ping this EC2 instance, the private one, I have to use the private IPv4 address, right? Because it's defined in this VPC, the range, the value, look like even if we have a look at the value here, it says 10.0028. Just by remembering the subnets that we made, we can see that this 28 is in the private one. So even the deployment of the server is correct based on the rules that we created. So now let's try to ping the private one from the public one. Now, nothing happens. Why? The answer is too simple. It's very easy. The answer is the security group of the private EC2 instance. So if we go to the networking for the private one and have a look at the, let's go to the security and then the security group, we can see that the inbound rule for this EC2 instance said that it only allows the SSH on port 22. So now what we can do is we can add a new rule here. I'm going to say for any ICMP, which is the protocol used for the ping, let me disconnect it here, you're going to allow it. So for any pinging from anywhere, so as I said, this notation means anywhere, you're going to be able to have a communication. So let's try the same command again. and it works. So right now we have a communication between the EC2 in the public and the EC2 in the private. And if we even think more about it, by setting things more properly, we can have a connection from our device outside of this VPC to the public EC2 instance, and then use the EC2 instance on the public to interact with the EC2 on the private, right? Now, creating all of this architecture used to be done. Like many years ago, you would have to manually do all of them. But right now, there are many other services that make things much easier. And the answer to that question is here. Let me show you the VPC. The answer is NAT gateways. So NAT gateway is basically the EC2 instance in the public subnet, which gives, so basically if you want to define it, NAT gateway is a service which allows services in the private subnet to interact with services outside of the VPC or with the internet in general. So it's one solution. Now, there are many services that we still have to go through them. For example, the Elastic IP, the NAT gateway. What if we want to connect two VPCs with each other, peering connection? And then also we have another layer of security, which is network access control lists, which sits on top of the VPC instead of the EC2 instance. So there are many other different features, but I'm going to finish this video here. I don't want it to be too long. I'm just going to have a very short overview on what we did, and then we're going to finish this video. So let's go back to the theory part. So this was the architecture that we made throughout this video. We defined the VPC, we defined the subnets, we defined the routing tables, we attached the internet gateway to the subnet, and then we deployed different EC2 instances in different subnets, and we showed that how having a service in the public subnet can have access to the internet, and how having it set up in the private subnet is not going to give it any internet access. Now, I hope you enjoyed this video. I really enjoyed this topic, and I really want to make the other parts on this series of videos. It would mean a lot if you like this video and share it with your friends. Thank you so much, and I hope to see you in the next video. Bye bye.